can you tell me what have you learned from your pre-reading about radical equations? What? Give me one very simple example. Try to get rid of the radical. Okay. You square both sides. But before you square both sides, what do you do? Oh, okay, at the end, if you want to solve something, you want to isolate the variable. But then, let's start with something easy, okay? Do you see? Get what? What would be a very easy problem to start with? How do we solve it? Okay?
Isolate the radical and then square it.
Okay, for example, if you have square root 2x minus 3 equals to, say, 4. Okay? This is a single radical, right? All right. And I would like to solve for the value of x, right? And that is inside this radicand. What can we do?
Square it.
You square it. Why you square it? Because if you square the left side, it will be the same that you square the right side. Yes? Okay? And when you square a square root, then you get the radicand back, right? Yes? So now you get 2x minus 3 equals to 16. And then we can solve x without any difficulty, right? So what is x? X is 19 over 2, right? And we can check. How do you check? Just substitute this back to the equation, right? 2 times 19 over 2 is 19. 19 minus 3 is 16. Square root of 16 is 4. Is that right? Okay. How about this? If I have 3x minus 1 equals to negative 2, what should we do? Same thing? Okay, people say same thing. And your same thing is you square both sides. Okay, I would say before you square it, you think. This is square root, which represents the principal value, right? It's always greater than or equal to 0, right? Could that equal to negative 2? No. So you don't even need to do anything. You say what? No solution. Right? Okay. This square root value represents the principal value of the square root, right? So it's always greater than or equal to 0. Am I correct? Yeah. Okay. So it's impossible to be negative. Therefore, you say there's no solution for this equation.
So when it's a negative number, it's no solution? Or just
If this is by itself, it's a single radical number. Okay? All right. So now next. All right. How about this? Now, I make it a little bit more involved that the left-hand side is not just have a radical number, but another term that is, well, next to it, it is a number, okay? What should we do? Okay. Previously, you have only a single radical, right? So when you square, you just get a radicand back. Now, how about here?
We say 5 minus 1.
Oh, good. Very good. So,
And then square.
very good. Very good. you do not want to square both sides at this stage. Okay? Why not? If you do that, what happens? Well, you are right. You can square both sides. Yes, nobody will say you are wrong. You can do this. But the problem is, by doing this, you are not making problems simpler. Okay? Lena, would you like to try what is the square of this? We just had the exam yesterday. You would have the square of this, which is what? 2x minus 3. Yeah? Okay? And then? That's it? Did you do this yesterday? What is the square of this? What is the square of this? Tell me. The square of this is what? A squared plus 2ab plus b squared. So tell me, what is the square of this? It should be what? It should be the square of this, which is 2x minus 3 plus 2a, which is square of 2x minus 3, right, times b, which is 1. And then plus the square of this, which is what? 1, right? And how about the right-hand side? It will be what? 25, yeah? So you see, by squaring both sides, you did not make problems simpler, right? You still have radical. Look at here. When you square, because it's an isolated radical, so you get rid of radical sign. Okay. Therefore, you say, hey, I do not want to square at this stage. We would like to do what Lena said. What? Isolate the radical, right? So you want to subtract 1 on both sides. Is that okay? Yeah. Question? Yes. Yes. And we should. And we have to. Okay. Otherwise, you will run into this situation that, see, you still have radical. So you need to isolate. Do not do this. Do not do so. Okay? You are not making your problem simpler. So what should we do? So this, don't forget, okay, my friend. You are my good friend. Don't forget about that. What should we do? So let me write again. 2x minus 3 plus 1 equals to 5. What you need to do is, the first step is the key. Isolate one radical on one side. Okay, so you would like to isolate it means what? You want to subtract 1 on both sides, yeah? So what do you get? You get square root 2x minus 3 equals what? 4. Is that okay? And then now it's isolated. You can what? Square both sides. Okay? And what do you get? You get 2x minus 3 equals to 16. So 2x equals to 19. Okay? And then x equals to 19 over 4. Okay? Actually, this question and that question are identical. I just make it add it by 1 on both sides, right? Does it make sense to you guys? Yes. Okay. All right? So what is the key? Can you tell me? Can all of you say out loud what is the key? Isolate what? One radical on one side. Is that okay? Isolate one radical on one side. Okay, we are going to restate what we have learned earlier. For solving a radical equation, what is the key? What is the key? You would like to what? Isolate how many radical? One radical on one side. Yeah? Okay, but right now, is that isolated? No. So in order to isolate it, you want to what? Subtract 1 on both sides. Is that right? Okay, so what do you have? You will have square root 2x plus 2 equals x minus 1. Yeah? The reason why we isolate one radical is because later when I take square on both sides, it will be easy. Yeah? Does it make sense? Okay, so now we would like to square both sides. Can I square both sides? Yes. And because it's already isolated, when you square it, we just get a radicand. What is a radicand, Luz? It will be just 2x plus 2, right? Okay, now Luz, continue. What is this? It will become x squared minus 2x. Wonderful. Plus 1. Awesome. Awesome. Okay? Now, this is an equation, right? This is just an equation that you love to solve. Maybe we can try to factor it. How do we do that? You will say, let one side to be 0. So you will what? Subtract 2x, subtract 2. Subtract 2x, subtract 2. Okay? Make this side to be 0. Then you will have x squared minus 4x minus 1. Is that right? Is that okay? Okay. Can I solve this? We want to factor it. Can we factor it? Well, right now, if we want to factor using integers, we cannot. We cannot. Okay? But you have learned something in the past. We call quadratic formula, right? If you want to solve a quadratic equation, right? You can what? Solve by quadratic formula. Does it make sense? Okay? Anybody remember the quadratic formula? Raise your hand. Okay, can you tell me what is that? Okay. Since it cannot be factored, okay, we may use quadratic formula to solve it. And somebody say, Dr. Chen, I totally forgot what is quadratic formula. We will go over that, okay? All right, so for those of you who remember, can you tell me what is that? It's x equals to negative b plus minus square root of what? b squared minus 4ac over 2a. Yeah? What is a? A is the coefficient of the leading term. What is b? Negative 4. What is c? Negative 1. Okay? I know some of you say, well, I totally forgot. We will go over that. But I just want to show you that it's not always you can factor. When you cannot factor, then this is something you are going to use. Okay, can you say what is that? 2 times 1, and then negative b is what? Negative, what is b? What is b? Negative 4. Plus minus square root, what is b squared? It's negative 4 squared minus 4a. c is negative 1. Are you with me? Yes? Okay. All right, so what is the answer? 2 is in the denominator, so you get 4 plus minus, what is this? 16. Negative 4 times negative 4 times negative 1 is what? Negative 16. Wait a second. Are we? Oh, what? This is 1, huh? 4a. A is what? 1. Sorry. So this is what? Plus 4. Yeah? Is that okay? Sorry. Okay? So what do you get? I will let you do it. Can you do it yourself? Simplify it. Only take you 10 seconds, right? You just had it yesterday. Okay, you have 4 plus minus what? Square root of 20, right? Over 2. What is square root of 20? 20 is 4 times 5, right? So actually 20, Since it's 4 times 5, so you can write it as 2 radical 5. Am I too fast for some of you? No, okay. What is radical 20? It's 2 radical 5, right? Can I simplify it? Yes. Because what? Because the 2 terms in the numerator has common factor. What is a common factor? 2. So I can factor out 2. It becomes 2 plus minus square root of 5 over 2. Now this 2 will divide out with that 2. So the answer is 2 plus minus square root of 5. This will be the answer. This kind of problem is a typical problem that we are going to assess students for the final exam. Okay? Okay, so let me explain why. And we are going to go over some of the details, okay? This is an equation involve radical, right? And not just one radical on one side. You have to think, you need to isolate it because when you square it, you would like to have a simple situation that you can just get a radicand, right? So the key is what? You want to isolate one radical on one side, and then you square. Is that okay? Now, after you get that, you will get a quadratic equation. If you cannot factor, then you have to use what? Quadratic formula. How many of you would like to go over quadratic formula one more time? Oh, yes. I think everybody.
Can we just have the equation
Yeah.
when you give us
You
that
mean
line?
formula? No.
Formula?
We will do it. We will do that. I know. That has been some time. I mean, since you learned the beginning algebra, okay? You have learned it in the past.
No, my professor didn't give us.
You must have learned that. It just you did not remember. Okay? Yeah, I know. Yeah, it's okay. It's okay. But we will go over that as a new topic. Okay? So don't worry. So let me give you something easy. I'm giving you this example up front so you know what do we need to learn. We need to learn what? Quadratic formula. How do you solve something you cannot factor? Okay? But once you learn that, okay, so we are going to derive this, then you can solve all the quadratic equations without difficulty. Am I correct? Okay? All right, now you do the next problem yourself. See whether you can do it. Okay? Example 4.
It's just hard remembering the formula.
It's just hard to what?
Remember that formula.
Oh, okay. Anything else is easy?
Or when you remember, put it in that form.
Okay. All right. Oh, what is A? What is C? What is B? This is A. This is B. This is C. Okay? All right. Now let's do next problem. Square root of 1 minus 4x minus 5 equals to x. Now I will give you 3 minutes to do it. Awesome. So can you all say out loud, what do I need to do? What is the key? Let's repeat. What is the key? Isolate
One radical to one side.
one radical on one side. It's not isolated. So how do you isolate that? You will add 5 on both sides, right? Can you tell me what is the principle or property that I'm using by adding 5? Why can I add 5 on both sides? Thank you. This is what? Addition property of equality, right? You always have to ask yourself why I can do this. Because this is an equation. It's like a scale. I'm adding the same amount on both sides. It's still equal. Is that right? Okay. So what do I have now? You will have square root of 1 minus 4x equals to x plus 5. Now what do? I will square both sides, right? When I square both sides, what do I have for the left side? 1 minus 4x. That is the advantage. We isolate the radical one radical on one side, right? Okay, now Victoria, what is this? Square of x plus 5 is? X squared plus 10x plus 25. Awesome. Okay, so now how do I solve this? You would like to make one side to be 0, so you subtract 1 and add 4 on both sides, right? Okay, that is what property? Addition property of equality. So you will get x squared, so you add 4x, so you will get 14x, subtract 1 on both sides, so you will get 24. Am I too fast for you? No. Okay. Can I solve this equation now? Yes, because you can what? Factor. How do you factor? X plus 2 times x plus 12. Okay? And that equals to 0. You learned that, right? Okay, in the previous course and this course. Now, if you have a product equal to 0, then one of the factor must be 0. So what do you conclude? X plus 2 equal to 0, or x plus 12 equals to 0. So what is x? So x equals to negative 2, or x equals to negative 12. Okay? All right. So am I done?
No, you have to check it.
You have to check it. Thank you so much, Victoria. Get extra point. We must check it. Okay? We must check it. Okay? You have to check it. All the equations, okay? Starting rational equations, when you have denominator, so you have some restriction. Now this is a radical equation, you have radicand, right? You also have a restriction. So you have to check for all those equations. Okay, so what are the equations you need to check? Well, you need to check for all, but specifically for the domain, you have to check for rational, for radical, and for logarithm. When we talk about the domains, they have specific restriction. Am I correct? What is the restriction for this equation?
It has to be greater than or equal to 0.
Thank you so much. The radicand. The radicand. Can I talk about something like this? Is this a real number? No, this is not real number, right? We want real solution. So you have to make sure the number that you found, the solution that you found, will make the radicand greater than or equal to 0. Is that okay? So you have to first check what? First, check if the radicand is greater than or equal to 0. Okay? Is that okay? All right. Is it true? Let's see. 1 minus 4. Okay. Okay, so 4. X equal to negative 2. 1 minus 4 times negative 2 is what? 1 plus 8, which is 9. Is that greater than or equal to 0? Yes. 4, x equal to negative 12. 1 minus 4 times negative 12 is, wait a second, is what? Is 1 plus 48, which is 49. Is that greater than or equal to 0? Yes. So means what? Yes, they just possible. So negative 2 and negative 12 are solutions? No, are possible solutions. Yes. Because we just say that they are in the domain. But I did not say they are solutions. Why? Why I put this possible instead of just say they are solutions? Because I have to check what? Yes, second. Okay, second. We have, or we must, check if the number makes the equation what? When you want to check true, thank you. Okay? Right? Do you know what I'm saying?
Yes.
Okay? We have done this starting week 1, right? What do you mean by a solution? You have to make the equation true or inequality true. Okay, I just say that they are in the domain. It's not enough. We have to also check whether it will make the equation true. So you have to check for both. For x equal to -2, let's check. Okay, 1 minus 4 times -2 minus 5. Well, that equals to x. X is what? -2. Check. Everybody check. So Alberto, what is that? It's the square root of 9. 1 minus 8. 1 minus -8 is 9. Minus 5. Is that equal to -2? So this is 3 minus 5. Is that equal to -2? Yes or no? Yes. So this got checked. The second one, for x equal to -12. Square root 1 minus 4 times -12. And then minus 5. Well, that equals to what? What is the x? 12, right? So let's see. What is this? This is square root of 49, right? Minus 5. Are you with me? Is that equals to -12? No. 7 minus 5 is not equal to -12. So what does it tell you? It says -12 is not a solution, right? So -12 is not a solution because it does not make the equation true, right? It doesn't make the equation true. So what is our solution? Only -2. Does it make sense? So the solution set, we usually will give a solution set, is only include one number, which is -2. We put all the solution in a set notation. That's called solution set. Is that okay?
Why do we have to put possible solutions when we end up solving the problem later?
Oh, I'm saying 12. Why you write this?
Yeah.
I have to teach you so you know what's going on. Okay? Maybe in the exam you will not write this, but you are going to check both. Okay? And I want to make it, clear to all of you that after checking the first, condition, it's just to guarantee those are acceptable. Okay? But acceptable in the domain doesn't mean it will make the equation true. So when you check for rational equations, for radical equations, and for logarithmic equations, you have to check two things. One is that in the domain? The second thing is that make the equation true? Does it make sense? Okay. I think it's a very good example. Do you get it? Now what I want you to do is I'm going to relocate you. And I want you to pair with someone and say out loud about your understanding of this. Okay? Yeah.
So the only time we use the quadratic formula is
when you cannot factor.
Okay.
Yeah. Does it make sense? Yes. So that's why you love factoring, right? Yes. Factoring saves you so much time. You don't need to use that formula. But if you cannot factor, don't force it. Just use the quadratic formula. Okay. If I can factor and if I would like to use the formula, I can use. But if you cannot factor, then you for sure will use the quadratic formula, right? We will go over the quadratic formula in the next few lectures, but not today. But yeah, yes.
If we do it the quadratic formula way, we end up plugging the radicals.
If you use the quadratic formula, where I will use the quadratic formula is here. I will say, okay, so where it's coming here, it will say x equals, let's try it. What is the a? A is what? 1, right? So negative b is negative 14 plus minus square root 14 squared minus 4 times 1 times 24. Yeah? And then 2 times 1. Yeah? This is the place that you use it, and you're going to find it's either negative 2 or negative 12. I didn't show you the process, but you will get it. This only tell you the value of.
Saying like a different problem that requires you to do a quadratic formula. You have to plug in the answer, which is the like 2 plus minus right 5 whatever. You have to plug it into.
To check this? Oh, yeah. Yeah, of course. Using quadratic formula just to solve this quadratic equation has nothing to do with this check. So, you know what I'm saying? Yeah? Once you find the solutions, you need to check for both, for sure. One is for domain, the other one is for whether it will make the equation true. Yeah.
So why didn't we plug in for the last example?
What do you mean?
The last example that we did, it came out a radicand. We didn't check.
We should check. We should check. We should always check. We need to check. Okay, we need to check for all the radical equations. Okay? All right, so I'm going to pair you up. You all have your, okay, only hold this note. You all have taken note, don't you? Yes. Have you? Yes. Stand up. Everybody stand up. I'm going to pair you up. Stand up. Stand up. Everybody stand up. Okay. You can. All right. I'm going to have you, can you line up? You lined up one line here. Yeah. And yeah, you were lined up here. So we only have 2 lines. You just need to find one line to belong to, okay? Can you do quickly? But you can hold just your paper of that note. Only that piece of note that you can hold. Okay? Can I have you all lined up quickly? Okay, everybody would go after Maricela. Okay, here. Move forward, move forward. Okay. All right. Come here. Can I have all of you come here? 1, 2, 3, 4, come here. Yeah, you come here. Yeah, you come here. Yeah, let's come. But 2 of you go the other side. Okay. Yeah, you come here. 2 of you will pair it up. Okay. And you come here. You will pair it up with her. And you will pair it up with her. And you will pair it up with her. Yeah. Okay.
My phone's ringing.
Now here. And then you will pair it up with him. Okay. And you will pair it up with, yeah, you. Yeah, okay. And you will pair it up with her. I mean, with her. Yeah. And you will pair it up. Okay. Can I have 4 of you come here? Okay. So there are 2 lines. I want you to do this. For the next 3 minutes, the left person, well, this side, my left hand, my right hand, okay, is going to explain to your partner. And then after 3 minutes, when I say switch, you are going to explain back the complete process of this equation. Okay? All right. So can you stand so that just come here. Yeah. So you will talk. Okay? All right. Start. Okay? They missed the middle term, 10x. Of course, you will not get it right anyway, right? So you have spent so much work, and you get what? You probably get 1 point. So this is a bloody killer.
Why? They don't boil correctly?
They don't foil correctly. They just don't remember this. So if any one of you that had that experience in the past that you lost this one, you better make a mark that you remind yourself. What else? When they check, they did not check the equation. Or some people did not check at all. Okay? How many kind of check you need to have? 2. One is for domain. One is for equation true, right? True equation. Is that okay? All right. So we are going to do one more problem. Can I have all of you do the next problem on page 527? Choose one. I will let you choose. How is that? You choose 2 or 3 problems, and then we are going to put on the board. Whoever can get them, whichever group can get them, you will get double extra point today.
Double.
Okay, choose one first. Any. I have a range. You have to choose one from 41 to 58.
What? 41 to 58? 520.
Page 527. Okay, I'm going to give you one.
What? I thought we choose it.
You're choosing one, but you're too slow.
I chose 46. I chose 46.
Okay, 46.
Because she said 41 to 58.
Can we do it now?
46.
46, go.
Wait, we can go on the board and do it?
Yeah, go.
I will put the rest on the board.
Can you do it on the board?
Yes.
You're gonna do it? No, I'm doing it. I'm not.
You can work in groups. What is the idea when you do the radical equation solving? You have to say out loud, isolate one radical on one side. How many radicals you have on one side for this question? 2. So what would you do? You would like to what? Isolate one on one side, okay? Great job. Okay, so now everybody do it. Everybody do it. We don't have enough time, so I will try to do myself. Okay, let's check the first one. Now you have one radical on one side, so they square both sides. Is that okay? Yes. And then you get 3x plus 1 here and 2x plus 1 plus x plus 7 on the other side. That's great. This is a very simple pre-algebra problem, right? Just collect the like terms. Okay? Collect the like terms. So subtract 2x on both sides. You get x here. Subtract 7. On both sides, you get x minus 6 equals to 0. So x equals to 6. Awesome. And then what's next? You need to check. What do you need to check? First, you need to check domain, right? So you need to put 6 into here. Oh, it will make it positive, so good. 6, plug in here. Yes, it will make it positive, so good. Domain checked. And then what's the next? You need to check whether it will make the equation true. So there are 2 checks. There are 2 checks. Okay, the first check is for the domain. And then this is the second check. Okay? Okay? And since you don't know, gentlemen, you don't know whether they are equal, you need to put question mark. Okay? Until you find simplified, yes, they are equal. So this makes the equation true. Okay? So x equal to 6 is your solution. Remember, I just said earlier, you need to answer in what? The solution set is what? Is a set of a number that is 6. Okay? All right. I have walked through and most of you got it right. How about to do this number 6? Well, what is the key? Okay. Isolate one radical on one side. Okay? Is the radicals isolated? No. So we would like to just keep one on one side. So let's choose one. Which one? It doesn't matter, right? So you probably would like to isolate this. So you are going to add radical square root x minus 1 on both sides. So you get square root 2x plus 6 equals to 2 plus square root x minus 1. Thank you. And then you square both sides. Yeah? Okay. So when you square both sides, what do you have on the left side? It will be 2x plus 6. You are awesome. Equals. All right. Now remember, this is a square of binomial. You have to remember you have what term? Middle term. Can you say? Middle term. So what is this? 4 plus 4 radical x minus 1 plus x minus 1. Awesome. Okay? Now, what do you see? You have the radical here. So again, you recite the key. What do we say? Isolate one radical on one side. So I'm going to isolate this guy. And the rest are going to go the other side. Okay? So I'm going to subtract 4, subtract x, and add 1. Okay, subtract 4, subtract x, and add 1. Subtract 4, subtract x, and add 1 on both sides.
Don't you combine the like terms first and then?
Yeah, you can do that. Of course. It's the same. Yeah. Combine the like term will be 3, right? It's the same. So what do you have? You just have 4 square root x minus 1 on this side. And how about here? You have x plus 3. Is that okay? Now you love this situation because what? The radical is isolated, right? So what do you do next? You what? Square what? Both sides. Okay? All right, Maricela. Would you like to participate and tell us what is this? X plus 3 square is what? So x plus 3 square equals to what? X squared plus 6. Wonderful. Plus 6x plus 9. Awesome. Extra point. Okay. So now you are going to continue. What about here, Maricela? What about this? That equals to what? You have 4 times square root x minus 1 square. So you will get what? 4x. So 4, you will have 4 square root x minus 1 square means 4 square root of x minus 1 times 4 square root of x minus 1. So what do you get? You get what? 16. And then times what? X minus 1. Yes. Wonderful. Is that okay for the rest of you? Yes.
Oh, I don't know how you get how you square 2 plus radical x minus 1. Like, how do you get 4 plus 4?
How do I get this?
Yeah, I get that.
Okay. How do I get this, Jeffrey?
Oh, because inside of parentheses it would be a.
There are 2 terms, right? Because a plus b square is what? Is the first term square plus 2ab plus b square. So the first term plus the second term square is the first term square plus 2 times the first term times the second term, which you get this middle term. Right? 2 times 2 is 4 times this. You get 4 radical x minus 1. And then plus the square of the second term. This is very important. So you asked a very good question, even though that we keep, mentioning that. Is that okay now? I wish no one in my class would make that kind of mistake in the future, okay? Because I just saw somebody, when they do this squaring, they didn't get it right. You have to be very, very cautious when you square two terms, okay? All right, now this is simple, right? What do you get? You get x squared plus 6x plus 9, and then equals to what? 16x minus 16. Yeah? And then you try to combine in like terms. So move okay, so you will have x squared minus 10x, and then plus 25. You are awesome. And this is what? X minus 5 squared equals to 0. So that's x minus 5 squared. This is a complete square, right? 25 is 5 squared. And the middle term is 2 times 5 times x, right? You must recognize this just like timetable, okay? We have done so much now, okay? This is a special factor, right? It's a complete square. Do you see that? Okay, very good. So what is x? So x equals to 5. Now let's check. Let's check. The first one, we would like to check the domain, okay? Is 5 making the radicand positive or 0? Yes or no? Yes, right? 2 times 5 plus 6, it is greater than 0 or equal to, right? And then 5 minus 1 is what? Is 4. Is that greater than or equal to 0? Yes, right? So yes, they got checked. What is the second check? The second check is what? See whether that will make the equation true. So we'll check the equation true or not, right? We want to ask. So plug it in. 2 times 5 plus 6 minus radical 5 minus 1. Question mark. Is that equal to 2? Yes or no? What is this? Square root of 16. What is this? Square root of 4. Is that equals to 2? So 4 minus 2. Yes, it makes it equal to 2. So see, it is in the domain, and it is making the equation true. So the solution set is a set of this number 5. Does it make sense to all of you? I'm very proud of you. You have to know this section kills so many students. It could be a problem that deciding whether this student can pass 131. This is, I'm not kidding you, this type of question is new or relative new to people who are in 131 compared with the previous, okay? So, do you learn well today? Yes. What is the key? Isolate one radical on one side. Okay. And what is the key when you square? You don't want to miss what term? Middle term. Don't forget about this middle term, okay? Okay? Yeah, okay. Now, the homework today, you will do this section. What is that section? 6.7, okay? You have online My Math Lab, right? And you also have extra point if you want to do, right? So if you can do it, you get extra point. It's going to help. It's already on Canvas. You all have it. And I want to make the, I see. Okay.